My name is Sudha, and this is the account management system I developed using C Sharp. This system is composed of multiple classes and functions designed to perform essential banking operations. The primary components include the bank class for managing accounts and transactions, the account class for storing user account details, and a set of transactions that inherit from the abstract transaction class. The program class acts as the main entry point where users can choose from options such as withdrawing, depositing, transferring money, or viewing transaction history. When a user selects an operation, the program calls the appropriate withdraw from account, deposit to account, or transfer between accounts. Each function uses helper methods to locate the specified account and validate the input amount. After successful validation, a transaction object is created and passed to the execute transaction method of the bank class. The execute transaction method then calls the execute method of the respective transaction class to perform the operation. If the operation is successful, the transaction is recorded in the transaction history. If not, an appropriate error message is displayed. The system also supports transaction rollback to the transaction method in each transaction class. This feature ensures that any failed or reversal transactions do not compromise account balances. This program is designed to perform basic banking operations, and it begins by allowing the user to select an operation. Depending on the chosen operation, it prompts the user to specify the amount and the account to enter. For withdrawals and deposits, the system checks the validity of the amount and executes the transaction if valid. For transfers, the system checks the source account has sufficient balance before proceeding, and once executed, the transaction is logged into the system's transaction history, which can be reviewed later. Additionally, the program has robust error handling to manage invalid inputs and failed transactions, ensuring the integrity of account balances. Now, let's delve into how the system incorporates key object-oriented programming principles such as abstraction, encapsulation, inheritance, and polymorphism. Abstraction in this system is achieved using the transaction class as a blueprint for different types of transaction. The transaction class defines the common structure behaviors like execute, rollback, and print, but does not implement them directly. Instead, derived classes like withdraw transaction, deposit transaction, and transfer transaction provide concrete implementations. This abstraction allows us to define a generic transaction handling mechanisms without specifying the exact details. And the second is encapsulation. The system achieves encapsulation by restricting direct access to the internal state of the objects. For example, in the account class, the fields name and balance are private, ensuring they can be only accessed or modified through the public methods such as deposit, withdraw, and print. This controlled access prevents external interference with critical data, thereby maintaining data integrity. And inheritance is implemented through the hierarchy of the transaction types. The abstract transaction class serves as a parent class, while specific transactions like withdraw, deposit, and transfer transactions extends its functionalities. This inheritance structure allows us to reuse common methods and properties, reducing code duplication while still supporting specialized behavior. And coming to polymorphism, in this system, it is evident through the use of abstract transaction type to reference different transaction objects. In the bank class, the transactions are stored in a list of transaction objects, allowing the program to call, execute, rollback, or print on any transactions, regardless of its specific type. This polymorphic behavior simplifies the handling of various transaction types in a uniform way. To summarize, the account management system leverages key OOB principles to create a modular, scalable, and secure solution for banking transactions. By using abstraction, encapsulation, inheritance, and polymorphism, the system efficiently manages different types of transactions while maintaining a clear and organized structure. Thank you.